disc and hollow cylinder. First, let us start with calculating moment of inertia of solid cylinder. Students, this picture represents a solid cylinder. We are interested in calculating moment of inertia of this solid cylinder about its own axis, which is represented with y dash. To do this, students, let us assume that this solid cylinder is made up of large number of elementary circular discs. Suppose this is a cylinder, it is having length L. About its own axis, we want to calculate its moment of inertia. This is made up of large number of circular discs, and these circular discs are placed one over another over the entire length L, and this makes up this entire solid cylinder. So first, students, we will calculate the moment of inertia of one such circular disc, suppose this disc, about the given axis, and then we will integrate that from over the length, means integrate from 0 to L, that expression, and it will give us the moment of inertia of the entire solid cylinder about its own axis. Let us do this. Suppose first we need to calculate the mass of this elementary circular disc. If M is the mass of this cylinder, M is the mass of the cylinder, then M by L represents mass per unit length of this solid cylinder. As let us assume that this elementary disc is taking, it's very small, so it is taking the thickness dx over the length L. So the mass of the disc, elementary disc will be mass per unit length into dx, that is thickness of this circular disc. Now we know the result that if we know this result that moment of inertia of a circular disc about an axis passing through its center of mass and perpendicular to its plane. This axis y dash is perpendicular to the plane of the circular disc. So the result we have previously calculated, it is 1 by 2 m mass of the disc into square of its radius, means r square. 1 by 2 m r square. We are going to use that result here. So the moment of inertia of the elementary disc about y dash, it will be I am using the result 1 by 2 m mass of the disc. Here it is m by L dx. Mass of the disc is m by L dx, and radius is same. The radius of the disc is same as that of the cylinder, so it is r square. Now this is the moment of inertia of the circular disc about the axis y dash. We want to calculate the moment of inertia of the entire solid cylinder. As I said that these circular discs are placed one over the another over the entire length, and this makes up the entire solid cylinder. So we will integrate this expression from limit x is equal to 0 to x is equal to L, and we will get our result. So the moment of inertia of the solid cylinder about the given axis, that is y dash, is equal to integration x is equal to 0 to x is equal to L, as all the circular disc will be placed over the entire length, m by L dx into r square, and when we solve this, we get the result 1 by 2 m by l r square, as these are constant, integrating dx results x, and when we put the limit from 0 to l, we will get the result as moment of inertia as 1 by 2. From here we get l gets cancelled, so 1 by 2 mr square. So this is the moment of inertia of the solid cylinder about the axis y dash, that is about its on axis. Now students, let us discuss the second case. The moment of inertia of the solid cylinder about an axis passing through its center of mass and perpendicular to its length. So this is the case here. This is a solid cylinder, and in this case this is our axis. So the axis passing through by symmetry from the center of mass, but the axis is not the axis of the cylinder but perpendicular to the length. This axis, now here I say it x dash, then it is perpendicular to its length. Length l is the length of the solid cylinder. Here again we consider, now this is the case, now this is the solid cylinder, now this way, and this finger represents the axis x dash, and it is passing through its center of mass and perpendicular to its length. Again we make use of the concept that this cylinder is made up of elementary circular disc. This circular disc, we are considering one such circular disc at a distance x from the axis about which we want to calculate moment of inertia, and of thickness dx. Now first we will calculate the moment of inertia of this elementary circular disc about this axis, and then we will integrate the expression from limit minus l by 2 to plus l by 2, as this end of the cylinder by symmetry, if this represents the origin, the middle represents the origin, then this coordinate is minus l by 2 and this coordinate is plus l by 2. So first we calculate the moment of inertia of this circular disc about x dash. Before doing that, let us consider an axis which is parallel to x dash. Let this be the axis. So now this axis is making up for the diameter of the disc. This axis, and this is a circular disc, and the parallel axis to this is this. So it makes up for the diameter of the disc. First we say what is the mass. Previously we have calculated the mass of the disc. So again I am writing mass of the elementary disc. With the same logic, it is m by l, mass of the entire solid cylinder. L is the length of the solid cylinder, so mass per unit length, and it is of thickness dx. So its mass will be the mass of the solid circular disc. It will be taking up what mass? M by l into dx out of this entire mass m. Now this axis makes up for the diameter of the disc, circular disc. Now we have previously calculated the moment of inertia of a circular disc about an axis which is representing its diameter, and the result was 1 by 4 mr square. M mass of the circular disc, r radius of the circular disc. by L dx r square. But we don't want to calculate the moment of inertia of the disk about its diameter, but about this axis. Students, this we have done intentionally because if we are able to calculate the moment of inertia of the elementary disk about its diameter, we can make use of theorem of parallel axis so that we can calculate the moment of inertia of this elementary circular disk about y. So now I am writing the moment of inertia of this elementary circular disk about the axis of r meters, that is about x dash. So I am applying by using theorem of parallel axis. So the moment of inertia of this about this, I will be writing it. It is 1 by 4 about this axis plus mass of the disk into x square. So I am writing here it is m by L dx r square plus mass of the disk m by L dx into x square, the square of the perpendicular distance between the two parallel axes. Now this is the moment of inertia of this elementary circular disk about the axis x dash. Now we want to calculate the moment of inertia of this entire solid cylinder about x dash. As I said that this solid cylinder is made up of large number of such elementary circular disks which are placed over the entire length. So we will integrate this expression from minus L by 2 to plus L by 2 and we will obtain the moment of inertia of the entire solid cylinder about x dash. So let us do that. Moment of inertia of solid cylinder. It is equal to integrating it from minus L by 2 to plus L by 2, 1 by 4 m by L r square dx plus m by L x square dx. Students, when we solve it, we get this result as 1 by 4 m by m r square m by L r square common dx x, when we put the limit L by 2 minus L by 2 makes L, so L gets cancelled, so we get 1 by 4 m r square by the first part, and from by the second part we will obtain on solving. You can solve it very simple, 1 by 12 m L square. So this is moment of inertia of the solid cylinder about the axis x dash, which is passing through its center of mass and perpendicular to its length. This article is very important from examination point of view, students, and it's very simple. You just need to remember the results of moment of inertia of circular disk about an axis passing through center of mass and perpendicular to its plane, which we have used here, and the other result, that moment of inertia of the circular disk about an axis which is acting as its diameter. If we know these two results, we can easily improvise on these results and calculate the moment of inertia of the solid cylinder. For this lecture, it is all, students. We will meet in the next lecture to calculate moment of inertia of annular circular disk, and from those results we will calculate how to calculate moment of inertia of